morning. Thank you so much for joining us. If some of you could start taking a seat in the back there. Welcome. My name is Austin Collins. I'm the founder of Serverless Inc. We're a company that makes developer tools for developers and organizations that want to build and manage serverless architectures. I just want to welcome you all to Emit, the conference on event-driven architectures. I wanted to go with Emit, the event-driven event, but that tagline didn't get much buy-in from our team, so anyway, here we are. The reason why our company is hosting this, and so delighted to have all of you join us, is that in the serverless community and in the serverless movement, there's a growing interest in event-driven architectures. And this is largely because the serverless architecture is mostly an event-driven architecture. And this pattern is still new to a lot of our community members, a lot of the people practicing serverless design right now. And they need help. And I thought this would be a great opportunity to get everyone together to start sharing best practices and learnings. In addition to this activity going on, there's a lot of other factors contributing to kind of a resurgence of interest in event-driven architectures in general, like IoT, for example, getting event data from sensors and devices. There's also a growing need for companies to be able to act and analyze data in real time. Furthermore, just generally scaling systems to build systems that are more resilient, more agile, with designs that are open-ended that you could continually add to. Also, developer productivity reasons, just enabling your team to work more autonomously, owning their own microservices and be truly decoupled from the system via event-driven design. Also, we see a lot of activity in event-driven architectures or in event-driven design on the browser these days with client-side frameworks like React. So all these factors are contributing to this resurgence of interest around the event-driven architecture. Some people think that it's used for specific use cases. Others believe that it's the native architecture of the modern digital business. And our company largely shares that belief. And that's why we brought everyone here together. However, there's just one big problem, and no one puts it more succinctly than a great analyst from Gartner, Yefim, who's actually joining us here today. And in one of his reports, he writes, "Building event-driven enterprise IT is not trivial and faces some significant challenges. The prevailing model of new application design is the basic request-driven SOA. There is no ubiquitous protocol for event communications that is comparable to the omnipresence of request-driven REST. There is no equivalent to API management for event processing. There are no high-productivity development tools that create event-driven solutions. And most developers have limited understanding of event-driven software designs. So for organizations aiming at excellence in modern business practices like digital business, IoT, interactive user experiences, and real-time business intelligence, these shortcomings will become intolerable." So we thought we'd use this opportunity to share learnings, experiences of practicing event-driven design, share best practices, as well as make some predictions for the future of what this architecture could look like, especially with these new technologies out there, like IoT, like serverless computing, all of that. So that said, we have hired a special architect, a special type of event-driven architect to help us initialize this conference. And what Steve here, this is Steve Price, ladies and gentlemen, from Steve Price Machines, right? He is a chain reaction artist. And the concept we tried to come up with here is an event-driven workflow that's meant to initialize the conference, essentially, by publishing a series of events and having functions that react to them. So, okay. Are we good to go? Should I set it off? All right, so this raises a series of events shown in signs, as well as functions that are also shown as signs, and let's set it off. So conference idea created, the speakers were found, so find sponsors function was initialized, the conference speakers found, event happened, then we raised a conference error. Uh-oh. Oh, but unfortunately we had a retry conference function, which reinitialized the conference. Conference initialized event was raised, and show logo function was fired. That was pretty cool, actually. Well done, Steve. I didn't know stuff was going to like fly out like that, too. Anyway, special thanks to our speakers for traveling all this way, especially our guests also, or everyone who's traveled a long way to get here, and our sponsors, of course. We appreciate all of you. That said, I'm going to hand it off to David Wells, our developer advocate over at Serverless Inc., and he's going to introduce the first speaker. So thank you, everyone.
Thanks, everybody, for coming out to the first annual Emit Conference and coming out to San Francisco. I've been working at Serverless for a little over a year now, and it's been an incredible ride to see. You know, we come from humble beginnings of Austin hacking away in a coffee shop in Oakland, creating the first version of the framework, all the way to today, where we have thousands of developers and companies building things in this new kind of serverless way. And it's really, really exciting to see and to be a part of. But we wouldn't be here without you guys, the community. So a big round of applause for you guys for coming out. Cool. And a lot of the serverless team is here. Raise your hands in the back, serverless team. If you guys want to meet with any of the team or have any questions, make sure to find them throughout the day. We have a great lineup of speakers today around the event-driven paradigm. I'm super excited to listen to all their talks. But without further ado, let's kick off the show. Our first speaker is Rob Gruhl. He runs the serverless team over at Nordstrom. They're building some incredible stuff in the open source world around serverless. So without further ado, Rob, take it away.
Thank you very much. Thanks. I'm really excited to share some of what our team is doing today. Good morning. My name is Rob Gruhl, and I support a small team of engineers at Nordstrom called the Technology Acceleration Group. For the last 3 years, we've been exclusively focused on serverless patterns and practices, both in production, proof of concepts, through workshops. In the last year or so, we've become exceptionally fascinated with event-sourced architectures. So I'm going to talk a little bit today about what we're doing in that area. So this is an image of our team that we used for a recent internal serverless workshop. These are great engineers on the left. And what I like about this is we're waving goodbye to all those old server problems, the cold-powered steamship. But kind of behind us is this new problems coming in. And some of you might recognize the guy driving that boat right there. And we like to just stay a little bit pragmatic about some of the challenges that we face as we take on some of these new architectures. And that's a little bit of what I'm going to be talking about today. So let's take a quick trip back. So back in holiday of 2014, I was working on the personalization team, and we had a simple feature called Recently Viewed, which basically rendered a shelf on the bottom of every web page and every mobile page, showing customers what they'd viewed. You view 10 things, and then you see those 10 things show up in the shelf. So a simple function, a simple feature, but critical to our business. It drove a huge amount of directly attributable revenue every day. The challenge with the existing system was that it used a combination of cookies and batch processing with some traditional server architecture behind the scenes, and it could get delayed by 15 to 60 minutes. There were problems with cookie settings. There were problems with multiple sessions or in private browsing. So we decided to do a proof of concept using this distributed ledger. It's also called a stream. It's also called a log. I don't think anyone's fully decided how to describe these things yet, but whether it's Kinesis or Kafka, we produced 50 million customer click events onto this stream, and then we used a serverless function to process that stream and populate a NoSQL database. So this was an incredibly successful experiment. We reduced the latency to less than 2 seconds. The cost came down tremendously, maybe less than $100 a day for this processing capability. It also allowed us to use that exact same stream to do some more interesting things like frequently viewed, maybe brand category affinity for personalization. So after that, we did a bunch of request response services, both in production and as proof of concept. And one thing that we found is anytime you have a lot of functions, you have a lot of serverless architecture, you need a deployment framework to kind of keep yourself organized. So we found the serverless.com deployment framework, and we were able to make a number of contributions that made it work well at Nordstrom. So this ability to update the framework, the responsiveness of the team, and the quality of the community is one of the reasons why we continue to use this framework and recommend it. So fast forward a few years. At this point, we have, I would say, on a given day, we have hundreds of millions of serverless invocations. We have hundreds and hundreds of serverless functions live. We have dozens of teams using serverless functions. And across all of these serverless functions, we found that when you invoke a serverless function, you're looking for an event. So you start looking through your architecture for events, like how can I pull events? I could streamify a batch. I could trigger off of something landing in an object store. And we started thinking about how can we have a better way of organizing these events and feeding them into these serverless functions. And it turned out that this was not a new pattern. This is something that's been kicking around for a while in various forms. And some people call it event-sourced architecture. You can also call it central unified log. You'll see, again, a number of different ways of referring to that. But what it basically means is instead of this connected graph microservices situation where you have to go and talk to an individual microservice, ask them to add an attribute, ask them to scale to your load, you have something more like up at the top where you have individual microservices either producing events onto the event stream or consuming events from the event stream. So it really simplifies how you think about your architecture and allows you to decouple those producers and consumers. There's a number of other benefits from a distributed system standpoint. As I mentioned, we're not the first to think about this. There's been a lot of people coming before us. This is some of our favorite reading that we like around event-sourced architecture. If you're kind of newer to things or if you haven't read this one, this is our very favorite. We ask every candidate that's interviewing with our team to read through this ebook and take Eric to coffee and talk about it. It covers a bit of the history of streaming and also the future potential of streaming, so it gives a lot of context. If you're more familiar with event-sourced architecture, this unfinished ebook by Greg Young we just ran across, and it is fantastic. It talks about a lot of the deeper and more complex situations that you'll run into in an event-sourced architecture. So highly recommend anything by these folks. They've done a tremendous job writing that. So let's jump into Hello Retail. So we were hooked on this idea of event-sourced architecture. What would the world look like at Nordstrom if we had one stream of product events, everything that's ever happened to a product from the moment it's conceived to the last item being sold on clearance? We have a stream of everything that customers have ever done, and we have a stream of everything our salespeople have ever done. Well, if we had that, it would really simplify a lot of what we do, and we'd be able to react very quickly and build new features. So we built a proof of concept called Hello Retail. So Hello Retail, it's an open source, 100% serverless, functional proof of concept, showcasing an event source approach as applied to the retail platform space. So I'll quickly kind of click you through what this might look like. If you want to see it live, I have it on my phone. It's easy to walk you through. So here I'm logging in. This is a static web page with React.js. I have my top-level navigation. You can tell we're a back-end team and not a front-end team by our beautiful UIs. I can jump in as a customer and view a number of categories and products. So I go back out. Now I'm going to register as a photographer. So here I put in my phone number that is produced as an event onto the event stream, and there's a microservice that picks that up. I go back into the menu. I create a new product. This product is cats that were found in my Airbnb. And that event goes onto the event stream. Now, when that event goes on the event stream, we have a category microservice that picks it up and populates the category list, a product microservice that populates the product details, but we also have this photographer microservice that says, do I have an available photographer? Go contact them using Twilio. That photographer takes a picture, responds. You say, thanks so much, Rob Gruhl. And now that image becomes an event on the stream. At this date and time, a new image is available. And when I go back in and I look at my website, there I have my cat. We also have a workshop that's associated with this where you will extend the functionality of this, and that's also available through open source. So here I've placed an order for the cats. And again, that order is just, again, an event produced onto the stream. So this is the basic architecture. The tube in the center is the ledger, or the stream, or the log. And it looks pretty complex. We've got, I'll just walk you through a little bit of what you're seeing here with this pointer. Okay, so here's these are traditional request response endpoints, as are these. And so for the clients, most of the time they're just thinking about calling an API like you would do before. And really it's the behind the scenes architecture that's changed here. The thing that makes me say don't panic here is that most of that is just configuration. That's just like a serverless YAML in the serverless framework. And there's only a small amount of code behind the scenes. So as usual, our team spent a lot of time writing a small amount of code, which is kind of how we like it. And each one of those lambdas might be 100 lines of code or less, and maybe a lot of shared code across those. All right, so given that kind of background, I want to talk a little bit about what we think we've learned about event sourcing, and as it's kind of a new endeavor for us. Any of you that have feedback, I'm sure a lot of you have been thinking about this for longer than we have. We'd really love to hear from you. Also, this goes up on YouTube. Comment below. We'd love to get your open and honest opinions. So we think that it's important to produce simple, high-quality events. So high-quality events are written in the past tense. At this date and time, this thing occurred. And it can either be an observation of something that happened in the world, like at this date and time, Rob started his talk. At this date and time, he finished his talk, hopefully on time. But it can also be the record of a decision. And this caused us to kind of twist our brains a little bit, because when you say something like, I'm producing an event onto the stream that says, at this date and time, Rob added this item to his cart, it hasn't actually happened anywhere. There's no database that's been updated. So I started to think about this a little bit like a royal decree. Let it be known that at this date and time, Rob has added his item to his cart. And it's up to all the microservices to scramble and go like, oh my God, I better like update a database or do something, right? So it's really the decision itself that gets captured onto the stream before any of the actual work occurs. We think it's important to swim upstream. So when you're thinking about your event source system, you say, okay, well, what is my source of events? Maybe it's a batch of data that I have or an enterprise data warehouse. Well, those events came from somewhere. So can you follow those events upstream? Can you find the original person or idea or system that generated those events? Because if you can, and you can generate the events at that point, it becomes more useful for all the systems down. You get fresher events with lower latency and maybe at a higher quality. Now, when we do design reviews and we talk about this, often people will say, well, I can't use that stream because there's something wrong with it, or it doesn't have the attributes. I really think this is super critical as you're making a transition into an event-sourced environment, is go and fix the stream. Find the team that runs that and help them out. Because oftentimes, let's say you're doing a loyalty reward system, what you really need is a omni-channel transaction stream, as does the personalization team, as does the purchase history team, as does the fraud detection team. So if you can all work together and find the source of this data and clean it up, everyone's going to benefit from that. As we've looked at streams, I think we found that there's two fundamental kinds of streams, and it's what I'm calling tech debt streams and published streams. So a tech debt stream might be something like you've got an Oracle database and you've got Golden Gate and you're doing a change data capture off of that and you're dropping it onto a stream and it's just blah. Right? You've got all these table updates, and it's really hard to understand. There's a lot of technical context. Now you have some stream processing layer, some stream transform layer that says, well, I'm going to reverse engineer all those table changes and turn them into an event, like this shirt now costs $10 less. That's the business event. That's the thing you want to publish. Maybe on a developer portal, you've got your request response APIs and their Swagger. You've also got your streams and their schemas. So you want developers to be able to subscribe to or attach to those streams. And so that's the published stream. And I think there's an interesting opportunity where you say, I have this tech debt stream and it's being transformed into this published stream. Maybe when I refactor the system in the future, the goal of that system will just be to publish that original event onto the stream, and I can replace this legacy system. So something to think about there. Ordering is a little bit controversial. You'll see a lot of systems that maintain ordering and systems that don't maintain ordering. We're trying to take the high road and maintain ordering across all of our systems. It's fairly difficult, though. Even once you've had those items ordered onto your Kinesis or your Kafka stream, or whatever mechanism you're using, there's lots of systems and libraries and tools and developers that want to process those events asynchronously. So here we have a chess match, with 51 different moves, and someone says, great, I pulled a batch of 51 moves, I'm going to process them asynchronously. It's going to be fantastic. We're almost at the point now where you have to do work to back off of that asynchronous reflex and say, no, we need to do this single-threaded, synchronous processing of these events, and that can be very slow if each one of those events needs to be processed with an external system. So we'll talk a little bit about an optimization that we've come up with for this a little bit later. Partition keys. Some teams say, I don't want to think about partition keys. It turns out we believe partition keys are really important because in a distributed system, in your partitions, it's only the partition key that allows you to guarantee ordering. So if you select customer ID, you're going to get that customer's events in order. If you select SKU, you're going to get SKU events in order. So you really have to think about with your architecture, what is the partition key and how are you going to use it? And if you don't think you need ordering guarantees or partition keys, I would ask, will any system in your entire system behave differently if those events were reordered? And there's some subtle ways that those those issues may come up. So really think about and make a deliberate decision about whether you're going to maintain ordering across your system and what your partition key is going to be. All right, so it's interesting that we've got, I didn't know there was going to be this magnificent Rube Goldberg machine over here. But one question I would have is, if this is Austin pushing the first domino here as the first event, could we trigger a serverless function off of that that kind of went all the way over here and did this? You know, can you bypass some of that intermediary system? So just like I mentioned swimming upstream to find the source of your events, can you also look downstream and look at what the effect is? Because maybe you can hop over a few steps there. You're not just transforming data and handing it to the next system. You're asking the question, what does that system do? And if I have a dedicated compute-intensive container working for me, can I just do that? So not always going to be the case, but something to think about. I mentioned this is a list of things we think we know. I think we're pretty sure about this one. Distributed systems are hard, and eventual consistency is weird. So it's a very different intuitive mindset. For example, you want to do a simple acceptance test. You want to add an item to your cart, and then you want to read your cart, and you say, I added this dress, and I went and I read, and the dress is not there. Is the system broken, or is it just eventual consistency? Or it looks different from the last time I saw it. There's all kinds of these really interesting and challenging problems that come up. We absolutely love this book. If you don't have this book, you should get it. It's Martin Kleppmann's magnum opus. It's like 500 or 600 pages long. It's kind of a 201 explanation of everything with tons and tons of footnotes and pointers. And the thing I love about this book is I read through a chapter, and the whole team is reading through this book. I read through a chapter, and there's a bunch of stuff I'm like, oh, I can use that. I really understand that. There's a bunch of stuff where I'm like, I have no idea what he's talking about, but I feel dumber, and that's an important thing, right? To understand what I don't understand, and there's always the opportunity to follow those footnotes and read those links. And there's some parts where he's like, this is a complex topic. If you want to learn more, read the textbook footnote. So it's like RTF textbook. Okay, so that's kind of what we think we know. Here are some of the areas that we're focused on and we're trying to figure out. So joins and aggregates across partition keys. So I've got two different partition keys, like maybe riders and taxis, and I've got a wonderful set of ordered events across those. But between those two streams, I can't make any causal guarantees. So if I replay it into this system as two streams, and then I go and I replay it into this system as two streams, I'm going to get a different ordering. So how do I deal with that? Two approaches that we're taking. One is you aggregate those two streams into a canonical join stream. And by canonical, I mean now everyone who wants that combination has to use that stream. And now everyone's going to agree on what that ordering is. The second opportunity, which I think could be an entire talk in itself and is super exciting, is CRDTs, these convergent data types. I mentioned at the beginning that our technology acceleration team has been focused on serverless. We thought that was a big deal. Event sourcing, we think that's a big deal. I'm guessing that this is going to be the next big deal because it allows you to do things like occasionally connected database, and you can do joins across multiple streams. And I think it just works really well with partitioned event sourcing systems. So we're going to be looking a lot more at CRDTs. Okay, so I kind of hinted earlier that there might be a better approach, and this came from an idea that Eric had, where I was saying I'm really worried about our fan-out lambda. We either have it asynchronous mode or we have it synchronous mode. In synchronous mode, I'm very worried about how slow it is. And Eric brought up the point that, strictly speaking, when you're doing ordering within a partition key, even within a batch of items within the same partition, you only care about the ordering for items with the same partition value. So here, A1 and A2 represent two items with the same partition value A and a value 1 and a value 2. You can split these events up and process B, C, D, E, and the A1, A2 group asynchronously, and only use your blocking single-threaded synchronous processing on A1, A2. So this is a hybrid approach between synchronous and asynchronous that we're exploring to see if we can get some performance improvements out of that. Effect after cause. So this one's pretty tricky, and it gets trickier when you have a system with multiple streams and multiple microservices consuming from those streams, multiple different databases. What you want to be able to say is, given that I've added this item to my cart, what are the contents of my cart? So 3 different approaches we're using here. The first approach, if you have the luxury of having a UI that can hold open a dynamic connection to your data layer, you can say, well, I'm just going to show the content of the carts, and as that item drops into the cart, it will show up, and maybe there's a bit of a delay. Maybe I can use some UI to represent that there's a dynamically loading view. And really, the latency here is usually on the order of seconds anyway, so maybe this is a perfectly acceptable solution if you have the luxury of having a customer-facing UI and this works for you. The second solution that we've implemented in production for a few of our systems is to put something like DynamoDB in front of the stream, and then you write through that DynamoDB and use DynamoDB streams in order to populate your ledger. And now you have an immediate read after write strong consistency. The thing I don't like about this approach is that it couples your event producer and your event consumer, and you lose some of that glorious, like, my job as a producer is I just throw something on the stream and I walk away, my job is done, and as a consumer, I'm just watching the stream. So we're doing a bunch of thinking and a little bit of work investigating this third option, which is, how about when I write to the ledger, I get a ledger receipt, which gives me my offset. So I say, add to cart, you're at offset 30, and then I walk over here to the cart microservice and I say, hey, cart microservice, once you've caught up to the ledger, position 30, can you tell me the contents of the cart? This gets, again, I mentioned, a little more complex when you have multiple layers. So now we're looking at using some distributed tracing ideas to trace that provenance of the event all the way through, and then update the database with a small graph that shows the relationships. So now I can say, all right, even though I'm consuming from this, I know that this links to this, and yep, I'm up to 30, so you should be good with this. So some really interesting things that start happening when you've got this glorious decoupling of your services, but then there's this question of, I throw this event out, what happened, when did it happen, and how do I synchronize across services? All right, so my serverless event sourcing wish list. As I tell my kids when they go to Nordstrom to see the Santa there, you only get 2, so I had to narrow it down to 2. The first one is a really big one for us, and this is we love the tools that we use, but there's a significant problem with fan out. So you've got this amazing stream that everyone's excited to use, and now you have 50 different teams that all want to consume from it. We use both Kafka and Kinesis internally. Kafka does this a lot better. The challenge I have with Kafka is you really need maybe 3 full-time engineers for the care and feeding of that cluster. So we'd like to be able to use a managed version of this, but the managed version is strictly limited. You can only do 5 reads per second. The polling frequency of the serverless functions is once a second, and this creates a significant bottleneck. The way we've solved this is we use a fan-out Lambda, and we fan it out to all of our subscribing partners. So you're responsible for standing up your own Kinesis stream. We'll subscribe you to that fan-out Lambda, and now we'll write to your stream. And now each team gets to manage that resource of their stream. The problem with that approach is now you have a single point of failure with that fan-out Lambda. Let's say somebody, one of your consuming or one of your subscribing streams, changes the policy, and you can no longer write to that. So now what do? Do you stop? Do you create a second fan-out Lambda and subscribe the kind of the sick fish stream? How do you do that? So it's a little bit clunky at this point, getting to that enterprise scale of, I've got a whole bunch of developers. You know, the end vision is I've got my developer portal with my APIs and my streams. I want anyone to be able to look at those streams and connect to one of those streams. All right, so I'm waiting for someone to make this magic button, because what I really want to do in an event source system is recreate application state from the ledger. So I've got my streams. I have some amount of durability on those streams. In Kinesis, it's up to 7 days. In Kafka, it's configurable, but really it depends on how much resources you're throwing against it, and at some point, you're going to have to write it to an archive. So I want the magic button, and my magic button's pretty specific. I have a team that says, we have a new feature. We want a request response API that tells you the average sales velocity by blush color of all cosmetics sold at Nordstrom. So I want to cold start a new database using the last 3 years of transactional events. So I want to do that using the same serverless function that I'm going to use on my live stream, because I want to write that function once. So I go in, I write my function. It says grab a batch of events. If it's a cosmetics event, look at the shade, look at the price, add the price to this table. I'm done. Really simple piece of code, maybe a couple hundred lines of code. I want my job at that point to be done. What I want to do is point that function at my archive, push the magic button, and have the entire archive replay through that function at scale. And at 10,000 times speed, I get 3 years of transactional data in less than an hour. Maybe I insert $50 or $100 for all of this massively scaled capability. And then once it's caught up, and that database is caught up to the archive, I want to attach that to my real-time stream. And so now I come back from lunch, and I've got this new capability on my system. So this can also be used for things like disaster recovery and a number of other capabilities. Most of the systems now will do a good job archiving, but we're still in search of a system that will read from the archive. Google Dataflow system has an interesting approach where it treats the stream and the archive very similarly. So we're investigating that as one possibility. But if you have any ideas or thoughts here, we would love to hear them. All right. So if you're new to serverless or haven't tried serverless, I'll do a shameless plug here for our open source project called Serverless Artillery. We have found internally at Nordstrom this is an excellent way for teams to get started with serverless because it's using serverless functions to test your existing architecture. So Serverless Artillery takes the artillery.io core that was developed by Hassie Veldstra and Shoreditch Ops, the good folks in London, and we've hosted that inside of a serverless function which can invoke as many serverless functions as you need to generate arbitrary load instantaneously. So you can hook this into your deployment pipeline. You can run it once a minute as a health check. You can run it once as an acceptance test. It's very versatile, and it's very quick to invoke and very low cost. So the nice thing in the way that this is a good step into serverless is in order to use this as a load test against your service, you have to solve problems like, how do I communicate with that service? What subnet is it in? What are the firewalls? What are my authentication and authorization concerns? How do I communicate the certs, et cetera, et cetera? Once you've solved that for this testing scenario, you've now also solved it for any functional serverless function that you want to communicate with your service. If you're thinking about event sourcing, we learned so much when we did the recently viewed tray. It's a very simple use case, but it's one that's very visible. It was easy for us to understand when things went wrong. It's very visible on the website. It's very visible testing. You can go and hit an A item and a B item and a C item and see if they show up. So there's a lot of subtle issues that you'll run up against. So if you can find a use case where you have high visibility and maybe low criticality to it, you can get started and start establishing that stream. And as you establish that stream, think of it in terms of a published stream. See if you can get it to that high quality published stream, and think about how you can load all the attributes that were observed at the moment of that event's existence. So thanks. That's all I have today. Would love to hear from you. And here's a list of the open source projects that I mentioned. Thank you.